average surface temperature is about 59 degrees Fahrenheit. It does not change dramatically during the day or night compared to the Moon's temperature range, which goes from about 220 degrees Fahrenheit during the day to about minus 300 degrees Fahrenheit at night. Why would the difference be so stark? Well, the Moon has no atmosphere. The Earth does, however, which is why when the Sun's radiation reaches Earth, some of it reflects off the atmosphere back into space. A relatively large amount is absorbed, and some of it refracts or comes right through Earth's atmosphere. Therefore, Earth does not overheat during the day. At night, the same atmospheric layer that shields us from the Sun's radiation prevents trapped energy from returning freely into space. Earth has benefited from having the layer in the atmosphere called greenhouse gas, which is responsible for keeping us just warm enough to make our climate livable. The critical point to understand is that what affects our climate. The Sun's radiation does not change significantly enough that we can even detect it in 10, 100, or even 1,000 years. We also know that we do not get any other impact from outside other than the Sun. Thus, the change in climate has to do with internal events on Earth, as is proven by scientists that greenhouse gas is the major climate factor besides the radiation from the Sun. The greenhouse gas works the same as a blanket that you cover yourself with at night. It keeps you warm. The blanket has no energy, it just keeps the energy coming from inside your blanket. And if you cover yourself with hundreds of blankets, it could quickly become unbearably hot. The same thing happens with greenhouse gas. When it becomes thicker and more concentrated, it makes the temperature on Earth to go up. Greenhouse gas consists primarily of water vapor gas, which constitutes 60% of all greenhouse gas and remains in the atmosphere for about 10 days. Carbon dioxide gas accounts for approximately 26% of greenhouse gases and remains in the atmosphere for about 100 years. Finally, methane makes up about 9% and remains in the atmosphere for about 10 years before disappearing into space. Thus, significant additions of carbon dioxide and methane during the brief period of time results in the expansion and concentration of greenhouse gas. The problem is that nature cannot get rid of overconcentration of carbon dioxide and methane from the atmosphere fast enough. The increase of the greenhouse gas leads to the extra heat and the acceleration of the melting of the glaciers and ice, which is leading to extra evaporation. And because evaporating water becomes water vapor gas, it increases the greenhouse gas. Then, increased greenhouse gas creates more heat and calls for more evaporation. It creates a positive feedback effect and a cycle that the planet cannot get out of by itself.